Students, welcome to lecture number 28. So, we have been discussing about the deep neural network and we will continue doing that today. However, we will talk about unsupervised learning of deep neural network. So, first let us see what so far we have done. So, DNN or deep neural network has three different categories. First one is supervised or discriminating, second one is unsupervised or generative, you can see here, and then hybrid type. So, first we discuss supervised one like MLP, CNN, RNN. MLP stands for Multilayer Perceptron, CNN is convolution neural network, RNN is regenerative neural network, recurrent neural network, sorry, not regenerative, recurrent neural networks. And today we are going to talk about unsupervised one, that is mostly we are going to talk about GAN, AE and SOM. So, then we will wind off this particular portion and come back a little later part about discussing this various advanced deep neural network models after a few lectures. So, as you know, DNN has various types of models available and all of them may not be required for material science modeling, and that is why you are not discussing all of them. But convolution neural network was very important for image processing, and we have seen that. Recurrent neural network or RNN and variants are good for sequential data or time series data, like you have a video or audio time series, how to use this. Then you also have generative neural network, this is V, generative adversarial neural network or GNN, and this we are going to discuss today, autoencoder as well as self organized maps, which is SOM. Some of these techniques which will be widely used in the material science modeling. So, first thing we discussed about this multilayer perception, it brings back the discussion again and again, because traditional neural network model started with artificial neural network, which is nothing but a forward directional neural network, and MLP is one of the famous ones, and it is formed by basically teaming many perceptrons with additional ones stacked in different layers, and these allow us to solve complex problems, very complex problem, because this mimic the human brain structure. So, perceptron is basically a simple thing like a neuron, but it can take both values from 0 and 1, basically binary digits. That is what is the difference between perceptron and neuron, and each perceptron in the first layer will take the inputs, and as you know, neural network or multilayer perceptron is a parallel processing unit. So, therefore, this input layer will send output to the next layer, which is second layer or hidden layer, and finally, it will go on, and then output will be received in the final layer, which is at the right end of the network. And this is a 3-layer network is shown here. It is basically known as a non-deep or shallow network, because it is only 3 layers. The moment there are 4 and more layers, we call it as a deep neural network, and that is why actually deep thing came into picture. Deep means quite large number of networks. So, MLP is basically very simple. It can have input layers with some bias, then you have some weights, and then you sum it over the weighted inputs as well as bias. Then at the next step we apply the activation functions, and finally you get an output. Remember, this particular thing is done in every step. This is just like a parallel processing. Again, you will also have same thing done. That is what is basically the typical feature of any neural network modeling. So, you are going to do it again and again. Finally, we arrive at a best possible answer which will be matching with your expected values or experimental values, whatever you are thinking, so that error can be minimized. And I talked about also some activation functions, so I am not going to discuss about it. There are many activation functions used. Most important was sigmoid, tanh, or ReLU, or even some other variation of ReLU networks. So, and every neural network, whether it is a deep neural network or normal ANN type, we have to use back propagation algorithms, because this allows to perform the backward passes to tune the weights of the network. As you have seen here, we are using different weights. Here although I have written everything W, but it is not W, W1, W2, W3, W4, W5, something like that, Wn, as well as you have bias, and this bias is basically to take care of things which are not tunable, or we add this bias to have a certain kind of variation of the values of the inputs. So, finally, backward passes are done to optimize or fine tune these weights at W. That is what is the idea of this. So, this is a very important algorithm commonly used to train all kinds of neural networks, and it is a iterative method, as you know, it is iterative backward pass, and it will always attempt to minimize the loss function or the difference between the known correct predictions and the actual model predictions. So, that is the idea. Now, how it is done exactly, that will be taught by the TAs when we will do the live sessions, how we can do in Python programming to take care of this propagation network problems, that will be shown to you. But I would want to tell you that please do attend these live sessions in every live session, so that you can get an understanding how this modeling will be performed. If you want to learn to model this model using AI/ML for material science problems, then you need to know how to do it, and that is why actually real challenges are there. I am discussing only the algorithms and the problem associated with it, how to take care of those. So, now then we talked about little bit about recurrent neural networks, right. That is what the major discussion happened in the last lecture. If you look at any traditional neural network, and the inputs and outputs are independent of each other, they are not connected each other, and also neural networks are actually kind of forward type here, okay. It goes from front end to the back end, it never comes back, right. Although there is a back propagation algorithm which takes care of the weights of the input, but that is a different thing, and normally the way neural network function is that it is in a forward direction. So, and inputs and outputs are independent of each other, but RNN is a typical network where output from the previous step is fed as input to the current step or even future steps also. So, in cases where it is required to predict the next word of a sentence, how do you do it? We need to know the previous words, hence there is a need to remember the previous words, otherwise you cannot predict it, right. You must have done when you type email or you type words in a social media networks, what do? You type something, then the next word automatically is suggested by the program itself. So, this is a typical behavior of recurrent neural network, and if you carefully see it, it means that we take the information from the prior inputs to influence the output and the output of the current output and as well as the final output. So, we take the information from the input as usual, but it is used to influence the second output as well as the final output, and that is why this is used for time series data or sequential data, that is what we discussed in the earlier lecture. So, fundamental building block, that is why in RNN is was as a hidden layer or a memory layer, right. That is called a recurrent unit, that is what is called a recurrent unit, and that is why it is called a recurrent neural network. So, this hidden layer is what is called a recurrent unit or memory layer. It maintains a hidden state of memory that is then updated every time or every state based on the current input. So, it is basically an process which will update the recurrent unit every time a new input is given. So, it allows RNN to retain the information from the previous time steps and enable them to capture the temporal evolution or temporal dependencies and also produce the predicted results in a sequential data. That is what it is. So, the most important feature is this hidden state, which you have to understand. It uses the same parameters for every input as it performs the same task on all inputs or the hidden layers. So, this reduces a lot of complexity. You have seen in case of neural networks, we can use different weights, but here we do not do that. We use the same parameters, weight parameters, because it performs the same task on the all inputs or the hidden layers, and that reduces the complexity of the parameters, and which is distinctly different from the other neural networks. So, why it is required? Because as I told you, most of the neural networks are feed forward neural networks, whether it is talking about MLP or you are talking about CNN, the feed forward neural network. That means what? It basically goes in the forward directions. Although it is a stack up of different layers, and these different layers are having different purposes, but the information goes from forward direction. So, that is why it is kind of a feed forward network, but RNN is not that. It implies a sequential data, and that is what is the important thing, and then output depends on the previous steps. Maybe I can show you that. That is what it is. You see here, the output depends on the previous steps. Okay, it is has a memory which it has to remember every time it does the operation. That is why output depends on the previous steps. And recurrent learns from the training input, however, distinguished by the memory. And I told you, right, this recurrent unit or a memory unit or hidden whatever is, it allows them to impact the current input and the output using this information available in the memories. So, therefore, it is very popular architecture. A lot of times it is used for long short term memory LSTM or bidirectional LSTM or GRU, which you have discussed, where the problem is vanishing gradient is very significant. And I told you what is our vanishing gradient, right. I do not want to go back to it anyway. So, there are three important RNNs are widely used. One is called long short term memory LSTM, bidirectional LSTM, okay, bi LSTM, and gated recurrent unit. Okay. That is what is the three different types of things which you use normally. Because fundamental unit is this recurrent unit, and that is why this unit is has a unique ability to memorize things or capture the sequential dependence of the previous inputs while processing. That makes it different. So, now the network can be of different types based on the input and output, like one to one. One to one is a very simple one. It is called Mandel neural network. This is very simple, in which you have only one input and one output. Okay. That rarely happens. Mostly you have multiple inputs or multiple outputs. The second type is called one to many. In this type, there is one input and many output associated with it. And the most important example is the image captioning, where given the image we have to predict a sentence having multiple words. So, I give one input as an image and I ask the software or whatever to provide the caption of the image, and that means a sentence, and that means it is a single input to many output. You can also have many inputs to one output. In this type of network, there are many inputs fed to the network, several states of the network, and that will generate one output. This is typically used in sentimental analysis. What is that? You ask the software to read, or this network to read one chapter of a book, and ask it what kind of sentiment is it. Very sorrow sentiments, it is a sentiment which reflects some kind of a happiness or whatever. Then it can tell is the informations are many, inputs are many, and output is one, right. That is what is another neural network. But remember, when they reads through that, this is widely used in NLP, natural language processing. That is why it is has to do this kind of jobs. Then you can also have last kind of network, which is called a many to many. In this type of network, there are multiple inputs and multiple outputs corresponding to problem. One example is language translations, right, very simple language translations. In language translation, we provide multiple words from some language as an input and allow it to predict multiple words in the second language as output, right. That is what is done. So, you could have done that, you could have translated from some foreign language to English. So, that is why you do many to many, right. So, you have understood, right, one to one, one to many to one, and many to many. There are different examples also I have given it. So, now question is, there are different types which we will not discuss, but now we will talk about little bit about today's lecture, unsupervised learning, and what are these. First of all, let us talk about what is unsupervised learning. Well, it is basically a very important area of machine learning or deep learning, and that reveals hidden structures or patterns without any label samples. I hope you remember that there are two types of learning, unsupervised and supervised. There is another type of learning also we discussed about it, which is reinforcement learning, but that depends on agent. Let us not bring it here. So, supervised learning means you have a input as well as corresponding output or data levels available, right. And in the unsupervised learning, you have only input, you do not have any output or data level available corresponding to each input. So, under such conditions, how do you find out hidden patterns or hidden structures, hidden features. Okay. That is what is the job of unsupervised learning. Now, we talked about in machine learning also, like clustering is one such unsupervised learning technique in machine learning, but DNN is different. So, in this kind of DL techniques or deep learning techniques, it is typically used to characterize what? Higher order correlation properties. Higher order means the correlations which are not very simple. In machine learning, we find correlations which are very simple, like clustering. In clustering, what we are doing? We are trying to find out how many points we can bring it together, right? You remember how we have done. We have started using a mean value and started calculating distance of this mean value from each of the nearby points. And if all of them fall same distances, then we call it a cluster. But it depends on that, we can have different types of clusters. We have discussed all these things, please go back to my lectures. But here we are not finding out any simple correlation properties. We want to find out or characterize higher order correlation functions or features, as well as joint statistical distributions of the visible data. This is important. Here in DL, you can also find out statistical distribution also, how this data are statistically distributed and how the associated classes are there. It can be easily done using unsupervised learning techniques. These are the two important aspects. One is to characterize the higher order correlation functions or properties, or second one is the joint statistical distribution. These are actually widely used in the DNN. So, as it investigates underlying relationship or underlying patterns or correlation in the data, that is why it is an effective tool for many kinds of problems like anomaly identifications, dimensional reductions or clustering again. So, we know a dimensional reduction, right, that is called a PCA, and we will talk about a Pearson correlation analysis, and that is something which relies on the DNN technique, unsupervised learning of DNN. So, when you have a large number of data, that is why the DNN works actually. You could remember the small data DNN is not good. So, large number of data, sufficient data, the interpretation of this kind of things, it provides very insightful information which can enhance the decision making as well as facilitate the comprehension of integrate data patterns. That is very important. What kind of data patterns are providing? Like you are talking about, let us say, sell of any item by a company. Let us talk about all these big geese like Amazon or Alibaba. When they are selling some products, they would like to find out integrate patterns in the selling pattern. That is very important, because that is how it can make you understand. It can make you understand that what kind of intercorrelation exists among the data, and this can be only done using unsupervised learning and deep learning techniques. Here remember, this network is not under any guidance of features. We have not placed the network under any guidance of features, rather it is going to find out higher order correlations from the statistical distribution from the visible data. So, in a nutshell, this is what actually the unsupervised learning does in DNN. But you know what is this thing? Basically, he has to use algorithms to find patterns in unlabeled data. That is what is the key aspects in unsupervised learning in DNN. You have a lot of data, you want to find some pattern or features, and so therefore, that is the key thing to develop this kind of algorithms. So, what is the key idea? So, key idea is during learning you have to have precise supervisory information or target level is not required at all, because that is what is required in case of supervised machine learning techniques or even some of the DNN also. But here you do not need any precise supervised information. As a result of this, we can find correlation of input data or features, even we can have data representations also. We will tell you today also how data representation is so important in today's way, because this has connection with the informatics. Remember, material informatics or data science relies on how we represent data. So, that is the key idea. Since it has no supervisory information, supervisory things at all required, we can actually find correlations of the input data or features or even representations very nicely using unsupervised DNN learning. What are the various components of the unsupervised learning? Well, there are 4 components. Let us discuss about that. First one is coder and encoder. Okay. What is coder and encoder? It is used to encode and decode the data. It is normally used to that, because that is what it is. Encoder basically responsible for transforming the input data into the lower dimensional representations, or on which neural networks can then used. So, what is the encoder does? It basically takes the input data and transform into a lower dimensional representations. That is very important, because then it reduces your computational time or the power, and then you apply the machine learning on this or deep learning on this. But a decoder, what it will do? It takes the encoded representation and reconstruct the data from it, and this is the architecture which is used in all unsupervised learning techniques. One encoder, one decoder. In fact, there is one unsupervised learning technique is autoencoder, which has this is automatically, or rather we will discuss about this built in. Second thing is called a latent space. What is latent space? It is basically immediate representation of the data which are created by the encoder has to be placed in somewhere. That is where the space it is placed. Usually it contains feature which can capture the important aspects of the structure of the data. So, it is this one, the abstract representation of the features that can capture informations are placed in a latent space, okay, which is hidden. So, encoder will transform this data into a lower dimensional data, right, and then you can store it, keep it in some space. That data is called latent space, and this is important because of the architecture, because it is what on which the deep learning technique will be applied. So, now once it is kept in latent space, what you do is basically we do a apply training algorithm or a neural network model. Unsupervised neural network models use this specific training algorithm to get the parameters. Some of these common optimization algorithms are stochastic gradient descent or ADAM. Stochastic gradient descent you can understand, basically it is nothing but gradient problem in a time sequence manner. That is a very common method which is used in training algorithms, but you can also use ADAM also. They are used depending on the type of model and the loss functions. So, what are the loss functions? This quantifies how well the model understands the data. That is very funny, right? If I tell the census, it quantifies how well the model understands data, because it does not tell you how they are connected. It is a common component for all machine learning or deep learning techniques. It basically calculates the model's output and then difference between model output and the actual measured data. That is how it is called loss functions. So, the backpropagation actually works on the loss functions. It tries to minimize the loss functions. That is what is the backpropagation technique. So, these are the different components of the unsupervised learning methods which always widely used in the DNN. So, now we will talk about few of these techniques. First, let us talk about what is auto encoder. So, as you understand, it is an encoder. We will come back to it, auto encoder, in a little moment time, what are different types, but first let us discuss what is auto encoder and what does it do. Auto encoder is basically one of the most popular network, very popular network, very popular DNN auto encoder. Let us discuss the first is that, and this is has a it will always work with high dimensional data. High dimensional data and then reduce dimensionality of this data. Dimensionality will be reduced. Why? Because it will allow us to handle the data or apply the machine learning model much easily. That is what autoencoder does, or sometimes people say it basically compresses the data, compresses the input and generate a code, compress the input, generate a code, and then this which is decoded subsequently. This is in subsequent steps. to reconstruct So, basically what it does, it compresses the input data on which you can apply a model, deep learning model, and then again you generate a code, that is what is deep learning model. This will allow, this will then which is basically decoded. Once first you compress the data by encoder, then apply a model, then this data is again decoded to reconstruct the data. That is what is done, that is done most generally in case of autoencoder. So, in a nutshell, if I can say it is compresses and decompresses data, that is what it is. So, this network knows how to compress and decompress data. So, in a nutshell, if I write it is a neural network, a DNN, which compresses and decompresses both the process. First compresses and apply the model and then decompresses data. This is widely used in image processing. If you have a large image which is not easy to handle data, it can widely use that. That is what this one do. So, they are all feed forward networks, as you understand. These are all feed forward network, not like RNN. Okay. This is a feed forward network. These are the important features of this autoencoders. But what are the different kinds of features it has? It has 3 features, remember, any autoencoders or any variants, it has 3 features. First one is a encoder, and second one is the encoder decoder, and also you have a latent space, right. There are 3 things it has: encoder, decoder and latent space. So, encoder will compress the data, latent space that is what is done. So, when input data is compressed, it will be compressed to a lower dimensional, that is what is the job of the encoder, lower dimensional called latent space, and then it will be decoded later on to reconstruct the data. The first part of neural network is to do with what is called the encoder, and this encoder facilitates effective data reconstructions. Okay, the encoder actually compresses data. And to facilitate the effective reconstruction of data, so decoder is used, reconstruction, and reducing dimensionality, and after the compressed data, data will be stored here. So, reducing dimensionality, learning features, denoising data. So, therefore, important characteristics are what? Why do you do that? Why do you are doing this compressing data? The characteristics are as follows. One is reducing the dimensionality. Second one, learning the hidden features. This is also typically important. And third thing is denoising the data. We will talk about it. In a moment or so. So, these are the important aspects of that, but 3 important parts are encoder, latent space and decoder. So, let us stop here this part of this lecture. We will take up the next part of the lecture and discuss in details.